All right, today we're going to be working on something called half reactions. We're going to be writing oxidation half reactions and reduction half reactions. Now, a couple things to remember from concept A is that an increase in oxidation numbers means that the atom has actually lost those negatively charged electrons, because remember, oxidation is loss. A decrease in oxidation numbers means that the atom has gained negatively charged electrons. So reduction is a gain of electrons. We've talked about some ways to remember that, like oil rig and Leo the lion goes grr. Alright, so a couple of things just to review is that in the following equation we would assign oxidation numbers first. So I'll just go quickly through those because we've talked about those previously. Because nitrogen increases from -3 to +2, it means that there is an actual loss of electrons. As it becomes more positively charged, we're losing those negatively charged electrons. So because there's a loss of electrons, nitrogen is oxidized. And then oxygen, which decreases from 0 to -2, means that there's a gain of negatively charged electrons. So oxygen is reduced. In this case, hydrogen is neither oxidized or reduced. So half reactions allow us to show the exchange of electrons in a redox reaction. For each redox reaction, we can illustrate half reactions. We have one half reaction for oxidation and then a separate half reaction for reduction. All half reactions follow the law of conservation. Law of conservation mass is that there has to be the same number of atoms on both sides of the arrow. Now we know this for regular reactions, including redox reactions in this case, but this is also going to hold true for half reactions. We have to have the same number of each atom on each side. All half reactions also have to follow the law of conservation of charge. The net charge overall must be the same on both sides of the equation. So here we actually have a net reaction where we can see that on the left-hand side we have a total of a +2 charge, and on the right-hand side we have a total of a +2 charge as well. So the charge has been conserved going from our reactants to our products. So here's an example of a redox half reaction. The electrons are on the left-hand side, or gain. This is very similar to when we wrote endothermic reactions, where energy was on the left-hand side when it was being absorbed. Same thing with these half reactions. Electrons are on the left-hand side or being gained in the reaction. Notice how the charge for iron goes down from left to right as it's gaining those negatively charged electrons. And remember, this would be reduction because of that gain of electrons. Here's an example of an oxidation half reaction. Here you can see that we are simply placing the electrons on the right-hand side. This is very similar to when we did exothermic reactions, showing energy on the left when energy was lost. So here electrons are on the right because they're being lost in this reaction. Notice how the charge for Fe goes up as it's losing those 3 negative charges from the atom as it turns into an ion. And then again, this is oxidation because of that loss of electrons being shown on the right. So here we're going to practice writing some half reactions. You're going to be given a full redox reaction, and the first thing you have to do, just like we've been doing before, is assign oxidation numbers and determine oxidation and reduction. So here we have oxidation of magnesium, and then zinc is being reduced, and chlorine is neither going through reduction or oxidation. So we are just going to basically kind of leave out chlorine for the next couple of slides. We're going to focus on magnesium and zinc. So here I've just transferred this over. We know then that oxidation is going to involve magnesium because it's going from 0 to +2, so that's a loss of electrons. So I'm going to start with writing magnesium on both sides, assigning their oxidation numbers, so Mg0, Mg +2, and then I've already decided that that's involving a loss of electrons. Losing electrons is going to be placed on the right-hand side. So in order to go from 0 to +2, it lost 2 electrons. Right, now with zinc, I'm going to go ahead and do the same thing, write zinc on each side, place their oxidation numbers. Here I know that it's going through reduction because there's a gain of electrons, and specifically in order to go from an atom to go from +2 to 0, that would be 2 electrons. So I'm going to fill in my 2 electrons on the left-hand side. And here I can see that not only am I conserving mass, but I'm also conserving charge, because however many electrons are lost throughout the oxidation half reaction has to be equal to the electrons gained in the reduction half reaction. Alright, here's another example. Go ahead, pause, and assign oxidation numbers. You should come up with the following oxidation numbers here. We have copper that's going through oxidation as it goes from 0 to +2, and then silver is going through reduction as it goes from +1 to 0 with a gain of electrons. So we're going to do the same thing, go through the oxidation and reduction half reactions. We already decided that copper was going through oxidation, so we're writing it on each side of the arrow, assigning its oxidation numbers. We can see in order for one atom to go from 0 to +2, we're going to be losing 2 electrons. And now for a reduction half reaction of silver, we're going to start again with silver on each side, fill in their oxidation numbers of +1 to 0. In order for silver to go from +1 to 0, it has to gain 1 electron. Now here we can see that for every copper that undergoes oxidation, it's going to release or lose 2 electrons. And silver is only going to gain 1 of those 2. So we have to balance out the number of electrons. So we're going to do that by multiplying the entire half reaction by a whole number. So in this case, we're going to multiply this by 2 in order to make sure that if these 2 electrons are given off, we're going to be able to gain those same 2 electrons in our reduction half reaction. So by multiplying 2 into the electrons and all the coefficients, we get 2 atoms of silver are going to gain 2 electrons to produce 2 atoms of silver with an oxidation number of 0. So now this is balanced, and I've also conserved mass by having 2 atoms of silver on each side. Okay, we're going to get into more examples as well tomorrow in class, where we're going to be working with a couple little bit more complicated equations. But make sure you have all your notes filled in. There's no summary or quiz for this, so just make sure you are ready with your notes.